Okay, stand by, everybody. Give others a little chance to get here. It's right 5:16 now. I'm going to start on page 552. This evening will be over before you even know it happened. I planned out carefully what I want to cover, and those last spots you need before you take the test on the 13th. Let me see who's here. Let me look. Oh, we lost somebody. Okay. Pilar, you're there, right?
I'm here.
Great. Terrence, you're there.
Yes, I'm here.
And Trevor, you're there.
Yep, I'm here.
All right, great. Let's give the others another couple of minutes. And we'll start page 552. Let's work on functions and some question identification with math. Let's do some reading drills. And I got a lot. Okay, good. Donovan's here. I knew he was on the way. He told me. Welcome, Donovan.
Hi.
All right, good to see you there, bro. Page 552. 552. My second class of the day. I feel punchy. I'm ready. Fired up. Usually the other class is another program because I do things for Princeton. This time was our program. I had to do the first session for the October prep. That's why I needed to slot us later. I'm glad you could accommodate. Sorry for the change. But we had a teacher that's unavailable for us today. All right, another minute. Christina's out reminding people. All right. Okay, let me make the screen bigger here. Okay, good. Move this keyboard out of the way. I won't be needing that. I don't think. Got a new board here. Okay, let's do functions. We'll be able to get through it pretty quickly, but I want to make sure you know all the tricks. There are a couple of tricks with it. Where I want to start off is by, I do have to type again, by shooting you the link to the Desmo SAT calculator. Oops, I didn't type it right. Stand by. It's right there. I'll put it in the chat again. There's the Desmo calculator in the chat. You may or may not need it. It's up to you. I will show you how it's used when it's appropriate. But I want to get you used to in the last session using it as an actual weapon. All right. Let's look at the goals for functions. You know what they are, but we got to learn it SAT style. All right, let's start off the day. Donovan, could you read where it says goals and then keep going? Page 552, everybody.
Okay. At the conclusion of this chapter, you will be able to accomplish the following: interpret function notation in a variety of questions, work with input and output values to answer questions about functions, identify the type of function based on the description, and use PITA, plugging in, and POE on questions about functions.
Okay, here we go. Okay, so you think of a function as a machine. You put X in, Y comes out. So f of X equals Y, or Y equals f of X. All right, here we go. Let's do some review here. I want you to do, this is good. Let's just do it as a review. I want you to try to do as many of these as you can. Oops, I'm on the wrong pages here. Here I am. These are the right pages here. All right. I want you to do 1 through oh yeah, 1 through 5. 1 through 5. Do they suggest a time here? They don't, so I will. 1 through 5, 7 minutes, go. And then we'll go over each one of these, okay? As a separate lesson. I forgot how I do this. See what you know about functions 1 through 5. Do 1 through 5. 7 minutes. I'll time it so you get used to the test, right? That's what the theme of today is, getting you ready for that test. Get your clock going here. Six minutes. Four minutes. It's 4 minutes. 4 minutes. Try to see if you can get to all of them. Answer something if you run out of time. Just put any old letter, right? Don't leave anything blank. Just under 2 minutes. Just under 2 minutes. Actually, closer to 1:35. One minute. Thirty seconds. Okay. Okay. I'll just go through and give the answers first. Yes, I will. I'll give the answers first. Okay. A. Number one is 35, which is C. Number two is C. So two is C2 also. Yeah, I hope that when you did this problem number two that you went ahead and used PETA, right? You plugged it right in for the X. You got both answers, I would hope. And determined whether the number was between the two. You can use your decimal calculator to look at a decimal if you have to. But really, you can probably figure it out. That's the best way to do it. Don't be afraid to use the calculator to see, make it into a decimal and see if it fits either. Don't be afraid of that at all. All right, number three should be B. B. Number three is B. Now I can go over any of these you want me to go over, okay? Number four is D. Number five is A. That's right, exponential is A. Okay, would you like to see any of these before we go on? Then I'll comment on them if I have to. Which would you
Can you explain
see? Explain which one?
number 5, please?
Oh, I'm so glad you asked that. Oh, I'm so glad. In fact, that's one of the things they do different than you do in school. And they're right. And actually, it's a quicker way to do it for life. What's the difference? Was that Trevor?
It was Terrence.
Oh, Terrence. Yeah, okay. Sorry about that, Terrence Trevor. So we'll read number 5. Terrence?
Okay, I got you. Each day, the volume of helium inside a balloon decreases by 1.2% of its volume the previous day. Which of the following best models the relationship between the volume of helium in the balloon and time?
Okay. Now go back and read this problem. Which you got right, right?
Yeah, I got that one right.
Okay, read that problem out loud.
Um, a newborn baby weighing 6 pounds needs about 450 milliliters of milk per day and needs approximately 75 milliliters of additional milk each day for each pound gained after that. Which of the following functions can describe the relationship between the baby's milk needs and weight?
So how much per day extra does it do? does it need? How much per milk? How much per milk? How much per day of milk does it need? What's right there in the question? That's part of the issue.
450
So you're not.
milliliters.
I want to make sure you understand why you got it right, and that's what people go. Oh, so how much per each additional each day?
450 milliliters.
Yeah, these 450
And
per day, and needs approximately what
75 additional.
for each pound after that. So there's a set amount each day. Yes,
Yes.
yes, it's a set linear amount. Set amount. So that's linear. I mean, you can count the days and know how much additional milk, right? All right. So now let's look at number 5. Read number 5 again.
Each day, the volume of helium inside a balloon just decreases by 1.2% of its
Stop.
volume.
Stop. Does it decrease by the same amount every day?
Yes.
No. It decreases by the same percentage every day.
Oh,
So when it decreases, say it was 100, it decreased 12%. It's now 88. So
yeah.
then it's going to be 12% of 88. No,
Yeah, I
it's a
understand.
different amount every day.
Mm,
Therefore, whenever you see a percentage problem, it's exponential on the SAT. And they're going to do it to you twice, and now you know how to beat it.
okay. Thank you, Mr. Wilson.
I guarantee, because somebody else here was wondering that too, I'm sure. And I was praying someone would ask, and somebody asked. So now you have this box here. Now you see why we teachers demanded this box. This is new for your manual. It's in your manual now, but it wasn't before. This is bomb important. There were 3 questions like this in Module 1 and 2 in Module 2 on the SAT in August. So clearly they don't think you know this, but the way I explained it was perfect. Let's have a reading of that. Trevor, could you read that?
Questions about function types are easy to recognize by their answers. Determine whether there is an increase or decrease to eliminate half the answers. If the function is changing by a constant amount with each new input, it is linear. If the function is changing by a percent or multiplier of the previous output, it is exponential.
Right. So it's pretty interesting when you go, if you use that literally on this problem here, you see the decreases. Everybody's, you see that decrease, right, Terrence?
Yeah, I see it.
Pilar, you see that?
Yeah, I see it.
Donovan?
Yeah, I see it.
So that means you can right away eliminate C and D, right? Now the question is it exponential or linear? And I told you when it's percentage, it's exponential. Okay, I think we beat that to death, right? They even added a view graph that we asked for 555 to be added. Because I don't think they teach it in school this way. How many people hear about it in school that way? I didn't think so. Yeah, I don't think they really teach. Now I do it after school, but then again, we in the ghetto, we can do what we want, y'all. All right, number 6, functions IRL in real life. Functions in real life. Why don't you look at this problem and then we'll talk about it. Go ahead. You should really concentrate on what technique you're going to use to solve these problems. And they try to help you down here. What technique can you use? We'll talk about techniques again in a minute in a very direct way. This is an indirect way. I'll give you 40 more seconds. This is one of those problems. Let's find out what we did here. What do you think, Pilar?
What do I think the answer is?
Yeah.
I put B.
And how did you come to that conclusion?
Well, I first added 60 to the 4,740 to find the OG amount, and once I got that, I knew it was 4,800, which I know is just 12 or 1,200 multiplied by 4.
That's pretty convenient to have it be 60, wasn't
Yeah.
it? The other way, that's probably the way many would do it. So I only care if you got it right or you did. Of course, a lot of people would just see it as a PETA problem, right? And plug in for X, because X is the number of performances. And so it's kind of the same way you did it, really. And the question is, does it equal 4740? And it does, yes. So that is the answer. Remember, you start with B or C. If you'd done 5, it would not have worked, right? Your target is 4740. You could do it with PETA as well as the way you did it, okay? Any questions on that problem? That's functions in real life. Okay. Let's go on here. Oh, yeah. Take a look at this one, see what you think. This is number 7. As we go through these problems, they get harder, right? Okay. Okay. Give me another 20, 30 seconds here. Sometimes this problem was a little problematic. this is some sort of a plug-in, right? Some sort of a plug-in here. Let's find out what we did, or did anybody get this one? Many times. If you're on the test and you don't finish this problem, just guess and go. Don't get hung up on stuff like this. Terrence, did you get an answer?
No,
You said no, right?
no, I said no.
What about Trevor?
I got A.
You got A?
Yeah.
Okay, what about you, Donovan? Did you get an answer?
I think it might be A as well.
Okay. What about you, Pilar?
I didn't get an answer.
Right. It's a tough problem. So I really want to stress that if you just take a guess and move, what would you have guessed, Pilar, if I said you can't leave it blank?
I wouldn't know because I got
But I don't want you to
tricky
leave it
parts of
blank on the
X.
test, okay?
Yeah.
Promise me you won't. Promise me.
I won't.
Yeah, because there's nothing
I
off.
guess I would.
There's nothing off for a wrong answer.
Yeah.
Go ahead.
I guess A because I guess it makes most sense, but I still wouldn't feel confident.
Yeah, because they feed you back to 100, right?
Yeah, and with the X is greater than or equal to 4, it just confuses me.
Yeah, it means you got to pick your plug-in could be X equal 4, but I always feel funny when I'm right on I would do X equals 6 because I know when X is 6, everybody, Y is 132, but I shouldn't say Y, should I? I should say H of X. I don't know. I guess H of X is 132, so the ordered pair is 6 comma 132, right? So that we know what it is when it's 6. We actually do. We supposedly know when it's 4, but I think you might have to do it twice if you do 4. If instinct tells me when we're right on the number, I'm gonna have to. Yes, Donovan. I'm sorry. Sorry, Donovan.
Oh yeah, I'm sorry. I was not to cut you off, but I was doing the math over again, and I think it actually might be C.
So it's not C either. It's actually B. And I think it works out when you start the problem with a number greater than 4. 5, I've never tried. My guess is 5, I would have gotten 2 answers or I wouldn't have been able to finish. We got a fraction, right? In fractions, there's no evidence we're going to have a fraction here, right? So the question is, which of the equations works out when X is 6 and H of X is 132? Because in the problem, they tell us the family of 6 pays 132. The 4 one, I agree with you, Pilar, is somewhat ambiguous because it says a family of 4. And theoretically, it could work with 4, but I think I ran into some kind of problem trying 4. Maybe it's the problem you guys are running into. I don't know. But I never, when you see greater than or equal and you're getting ready to use plug-in, I would really go greater than the number. I just know from experience. And again, this is problem number 7. So it's a hard problem, given that they get progressively harder. And we're only going to get 10 problems in here, or maybe 9. Okay? So this is a progressively harder situation. So X equals 6, Y is 132. If we try this one first, right? 96 plus 100 is not 132, right? 16 times 6 plus 100. Again, I'm using plug-in, right? Is it 132? No, it's 196. So we get to B, let's see. 16 times, what am I doing? 16 times 6. But this one is 36 now, right? Plus 36 gives me 36. It does give me 132. Remember, on plug-in, we can just stop. Well, it's kind of a P-ish. But if you don't believe me, you check this one. This is for Donovan, I think. 22 times 6. We're already 132, right? Plus 100. It's not that one either. And you can see down here, it's just not going to work out. Oh, actually, it's interesting. Oh, no. 20 D is disqualified because 22 times 6 is 132. So actually D could work. But what happens is when you pick D, what is it? 22 times, oh, I just noticed this. It's 132 also. So what you would do is then go, okay, then it should work with 8, and it won't work with 8. And then you realize that B is the answer to the problem. Now I'm going to ask them about that because that's interesting. I think the other version had 20x down there, and this one has 22. So this is a question for Princeton. But you get the idea how I did this. I just used what's in the problem, right? And I said, well, these are the things I can start with and find out which ones of these work. Well, now that I think about it, yeah, right. So D could work too. So I'm going to ask Princeton Review about that. 4, I'm not sure if you can get a conclusive answer. I mean, if you have 4, it'd be 64. Oh, 4 is 100 though, right? Yeah, you could. 4 is 16 times 4 is 64. Pilar plus 36 is 100, and you're looking for 100, right? For a family of 4. So I don't know. I think it should have worked. But the key is your plug-in technique, is whether you have the right technique. So it sure looks like we're getting B with either 4 or 6. With either 4 or 6, and we're not getting this one down here. Okay. Again, that problem's a little messy. Fortunately for you, not too many of those on the test. Okay, keywords. Let's go on. All right. Now the dreaded day has come. Number 8. And then we'll move on to something else. Number 8. Then we'll move on to something else. Try number 8 for a minute and a half or so. You got these tables here. Pretty straightforward problem. But they count it as hard because of your technique. It's all in what your awareness and technique is. Take another 20 seconds. You should be able to. Okay. Terrence, what do you think?
I got
So what did you use for X? Or how did you attack it?
I just plugged every X value into
Yeah. And they're all 2, 3, 4, I believe. Yeah. So when you plugged in 2, could you eliminate anything?
Yeah,
What did you eliminate when you plugged in 2?
B and D.
Right. And then you went to 3. What did you eliminate?
A.
And what's the answer?
C.
I like that you did it with plug-in. I like that you did it with patterns. That's the quickest way to get to this answer, folks. You every time you plug in something, look for something to eliminate. Plug in, eliminate. Plug in, eliminate. That's how you're going to get through this. This is supposed to be number 8. That's how freaking hard it's supposed to be. But when you use technique, look how easy it was. Any questions on that problem? Okay. So once you see the 328 works, you know 29 already worked. You don't even have to check 465, right? All right, that saves you time right there. All right, I got to do it. Number 9. And it's a fill in, it's not a multiple choice. Try number 9, see what you come up with. Again, I know I'm doing harder problems today because we noticed the functional ones on the SAT were a little harder. We won't bother with 10 and 11, they're just super hard. You might want to try them on your own, 10 and 11. Look at them again. Yeah, 10's actually a lot of fun. 11 is not bad either, but you don't have to worry about those today. Give you a minute on this. This is a lot like the family gym thing. Kind of a doozy, but these are the kind of problems that if you get them, it can only help. If you don't get them, it's okay. If you get them, it can only help. – 40 seconds. Let's take 40 more seconds. Time. Okay. This is not a multiple choice. So clearly, if you just put in, f of 3 is 37 times c to the third power, and you got to solve for that. It's not easy, uh, particularly since you don't know what f of 3 is. So the only solution here when you get a problem like this is to solve for c with what you do know. Solve for c with what you do know. Did anybody get an answer for this before we go for f of 3? All right. So let's go through it step by step. So there's the equation. We know that f of 2, so when x equals 2, this is what my scratch paper looked like. Then f of 2 is 592. Or I could say y is 592 when x is 2. When x is 2, y is 592. That's what the problem says. It's given in the problem. It's shown in the problem. So then with that information, we can use this equation right here, right there, and solve 592. I couldn't write on the test on that, right? I'd probably reproduce it somewhere. I write it on the scratch paper. So 592 is equal to 37 times c squared. And it's c squared because x is the variable there. It's 2, x is 2. All right? So then what we do is we divide 592 by 37. It doesn't look convenient, but it's 16. 16 equals c squared, and plus or minus 4 equals c. But we have to reject minus 4. So 4 equals c, or c equals 4. So with c equal to 4, we're almost done because we continue on the same way we did before, right? You plug in x equals 3, so that's what we're looking for, f of 3, and c equals 4, right? And you get that f of 3, which is a number, is 37 times 4, c is 4, 4 to the third power, which f of 3 becomes 2368, and that's it. Now, you're going to see at least one problem like this where they have an equation that you never saw before, but you're going to have to find out what C is. And you're going to have to use what's in the problem to find out what C is. And once you find out C, that means you know the function, right? 3740 to the x. Now you put in x equal 3, you can solve it. There's another way to do this, but you'd have to know how to do the cube root of some really weird fraction, and that's hard. Usually, it's not going to work out well. But again, I can't stress enough what I'm going to tell you here. If you find that you cannot do the problem, don't mess around with this problem so long. I know it's a fill-in, but just move on. Don't get hung up on this stuff, okay? The only thing that made it hard was that it was a fill-in, because if it was multiple choice, you could use PETA, right? So you're going to have some fill-ins with hard problem here or there. If you can't do it, just skip the next. You can still get a high score. I had somebody on a practice test in this group I'm running now, got a 780, but got 4 questions wrong on the math. So you probably won't get them all right, but you can get a good score on the test and have a number of questions wrong. I really hope you see that when I'm showing these harder problems. Okay, I wish I had time to do 10 and 11, but I hereby pass. Oops. But that's a good one for you to try. It's a very direct problem. It's a story. It tells you what to do. So you might try that. Okay. And what can I say? All right, go to page. Let's do this real quick. Go to page, then we'll do some reading and do some reading drills when we get back. I want you to go to page 560. Page 560. does this say here? Yeah, that's a good point that I did these problems in bite-sized pieces. Okay, could you do as many of the problems as you can do? This is a good time to practice on your personal order of difficulty. What can you handle? Some of these things you learned when I discovered you with you a moment ago. And again, be able to understand the things that you should skip and the ones you should do. You know, and I know it's only 5 of them though, okay? So I'm going to give you 7, 8, I'll give you 8 minutes to do the 5, okay? And they get harder as you go through, just like on the test. And these particular problems are very good because they're similar to the kinds of harder and medium hard problems you'll see on the SAT. So after this, we'll take a break, but go ahead and start on these, okay? And then I will break and then we do some drills after that. Okay, go ahead and start through these. I'll time you 8 minutes. 8 minutes.
Are we just doing 1 through 5?
Yeah, only one. There's only 5 anyway. Just 1 through 5, Pilar. Do the best you can, all right? I know these are harder. I get it. Fortunately for you guys, function problems are not plenteous on the test, usually only 3 or 4 questions. But I thought I should include those in today's discussion. 8 minutes, go ahead. We'll come back and hit question ID in the math. You see that familiarity? There's different gears against each other very early. 4.5 minutes, 4.5 minutes.
Was big guy. That didn't work either. There were so many times in that playoff game, Mike, that when they were able to get him on the ground, one safety.
3 minutes. Two minutes. 2 minutes. Forty-five seconds. 45 seconds. Okay. So I'm interested in how many of these you could actually get to, because they are a little tougher. Let's see, how many did you get to, Pilar? There's only 5, but how many did you get to?
I got to, I think like 2.
2 of them, okay. But did you actually see number 5? Did you stop and when you couldn't do one and go on to see them all, or did you just go ahead and
Yeah.
all 5?
I would stop and then go to the next one, but I
Good,
only got to number 4.
good. All right. Anybody else? What's your experience, Terrence? These are harder problems.
I was able to get through. I was able to get through almost every problem besides 1 and 4. I couldn't really figure those two out.
A 1 and 4. So one you're going to kick yourself. I'll do that for you in a minute. 4, I understand. I kind of, yeah. I understand. Yeah. You know, but it decreases by 25%. So you start at 24, right?
Yeah.
Equal to, it's 25 over 100 times 24, which is conveniently comes out to 6. And then you get 18, right? Then you do 3, increase it, you just slowly go through it and you get to it. That's bad. You just keep moving. So in these
Okay.
percent problems, you know, these exponential and percent problems, you just have to be really systematic. 5 is the real one that's really super hard. But I would look at 1. I will look at 1 and 4, and then we'll move on to something new. I'll give you a break, actually, is what I'm gonna do. So there we go. There's F and G, and it says 2 times F of 3. So I guess we got to find F of 3 from here. And this is my scratch paper here. F of 3, which is the number, is equal to 2 times 3 minus 3, right? Which is 3. 6 minus 3 is 3. Then we got to do G of 3. Notice I didn't do the multiplication yet. G of 3 is simply 1/3. So now if I want 2 times F of 3, right, is 2 times 3, plus 3 times G of 3, which is 1/3, I'm going to get 6 plus 1, which is 7. There's my answer right there. Okay? It just literally, what this is testing is, can you read what this functional statements are saying? F of 3 means plug in 3 to X to find out what F of 3 is. And it's always going to be a number, right? Because you're going to put it, it's a function of X. There was a problem earlier where we had 2 variables, but don't worry about that. So this is a good number 1. It was just a plug in and then follow the directions for 2 times F of 3, 3 times G of 3. Okay? Is that clear to everyone, this one? Number 2, that's stupid. Alexa, hold on. Number 4 is, I love number 4. Read number 4, Pilar.
Number 4?
Yeah, read it out.
The value of the function g of x decreases by 25% each time x increases by 1. If g of 1 equals 24, what is the value of g of 4?
Okay, so that means, oh, I'm sorry, I need to change my page. So that means that when x is 1, right, it's 24. When x is 2, right, it's 24 minus what, Pilar? When x is 2.
Wait.
Read the first sentence.
25%?
So how much does it decrease by?
25%?
Of what?
24?
Ask me or tell me.
Telling you.
Yes. 25 over 100 times 24. Right?
Mm-hmm.
Yes? So if we do this, what do we get? Right? So let me just work right through it here. Of course, you can use the calculator anytime you want, right? So you can do this thing and you get 6. Well, 4 goes into here 6 times, into here 25 times. So you can see that it's 24 minus 6 or 18, right? So when x is 2, f of 2 is 18, right? G of 2, this is G, right? So now they want to know when x is 3. What do we do, Pilar?
It's 18 minus 25 over 100 times 18.
Yes. And what do we get? We get 18, these little dirty dogs, minus 4.5. You can figure it out, but it's 4.5. I just did it in my head here. But you guys can use a calculator. And you get 13.5. That's what goes here. It can be plugged in there. Okay. You can, that's a good decimal to put in there, of course. Okay, somehow if you get 27 over 2, there's a way to get that, which you just use, decimals, right? Or 54 over 4, those are also correct answers. But I think if you just do it straight up and follow the directions, I mean, the only time you get into decimal problems is right here on the last step. Because when you work this out right here, right, if you use, I guess, 2, you'll see what happens here and you get a decimal number. Okay. Now I won't show you any more of those. I know we need to move on. I want to give you a break. It's now 6. Wait, look at that hour. Just went by more than an hour. So take a break. I better give you till 6:30. Yes?
My mic was working, but I had a question on number.
Oh, I'm sorry. Yeah, go ahead.
Right.
Which one?
Number 3.
Oh, what about 3? Okay, 3.
I didn't know how to solve it without having to plug it in and plugging it in for x and trying to multiply it every single time was very time consuming.
Yeah, I know.
Is that the way we're supposed to do it? And I didn't.
Well, what did you do first?
Well, I also ended up just like giving up and then
Well, let's
skipping.
just see. So maybe we can make it a little easier, right? You look for keywords when you get a problem like this. When
Could
you
you show number 3
Huh?
once?
Yeah, I'll put it up. Number 3. I'm reading it. I was just reading the problem. I should probably put it up here. I forgot. Hold on. I'm having trouble finding my cursor. There it is. This one right here, right?
Mhm.
So when we read the problem, I'm going to read this one. The profit of a certain company can be expressed as a quadratic function P of X, where P is the company's profit in thousands of dollars. Got it. And X is the number of units sold in thousands. If the maximum profit is 90,000 and occurs when 4,000 are sold, okay, which of the following could represent P of X? So first of all, make sure they're all quadratics, and they are. Sometimes you can eliminate that way, right? Well, when X is equal to 4, let's see if we can find out here. Oh, when X is equal to 4, which is really 4,000, understood, Pilar?
Yeah.
See, X is 4. That's how you make your number small. Because
Yeah.
it's set in thousands, right?
hmm
So when X is 4, P of X is what? It's the key to the problem.
P of X is 90,000.
Nope.
Um,
Terrence, are you listening to this?
Yes, I am.
What's P equal to? What's P of X? She said 90,000. I said no.
Honestly, I don't know.
Okay, yes, you do. Whenever you get to that place on a tough problem, read the question. What does it say P is?
The company's profit in thousands of dollars.
Stop. Pilar, how much is P of X?
um,
Don't bail, don't bail out on this problem.
is it 9?
You asking me or telling me?
Telling.
Well, yeah, tell me. Come on now. So you see the key to this problem? That's make smaller numbers. No,
Yeah.
right? So with that in mind, I just plug in and eliminate.
Okay.
When I do that, I find out the answer is C.
Okay, thank you.
I'll let you do that on your own, okay?
All right.
So what seems to be the theme here on the harder problems? You got to burrow in there and read the questions. It's the company's profit in thousands of dollars. The number of units in thousands. They're letting you break it down. But then they throw a curve, right, Pilar? They go
Yeah.
back to using these terms. Those dirty dogs. But I told you that's why I don't like them. And I hope I can get you. That's why I hate them. I'm trying to get you to hate them. So when you go in there, you look for these tricks. And this only comes up on problems that are medium difficulty. They would just tell you they would say 9 or something, let you know it's really 9. All right, good question. All right. So with that was a good stop there. So let's do this. Let me give you a break. You guys have been working super hard. 80 minutes. I've broken every rule. You're going to break until 6:35 because y'all went really far on that. And I'm going to give you 2 reading drills to make sure you're sharp, right? And then I want to do rhetoric, which we haven't covered, transitions and synthesis. And then once I've done that, what do you say, another writing drill, a writing drill then? Okay, that's what I have planned for today. And a few encouraging words about the September and something I might be willing to do for you if you want me to next week. All right, let's take a break till 6:35. Okay? 6:35.